An ESP32 microcontroller with a built-in camera lets you explore a whole range of image processing applications, from time-lapse photography to motion detection and facial recognition. Add an LCD touchscreen and you've got a great little unit for some fun projects. So let me show you how to get everything set up. Hi and welcome to Bytes and Bits. The ESP32 microcontrollers from Espressif come in a wide range of configurations. Now, some of these provide dual-core processing with plenty of flash RAM and megabytes of extended pseudostatic RAM, and these make incredibly powerful little devices. Now, this processing power is ideal for small image processing and machine learning tasks. Now, you can buy a range of ESP32 modules with a built-in camera that allow the microcontroller easy access to a live video stream. And they do come with a range of example applications to show this working. But a lot of these use the ESP32's Wi-Fi connection to create a web interface for the projects so that you can actually see the images. But luckily, the kind people at Elecrow have sent me one of their ESP32 camera boards with a built-in touchscreen LCD display. Now, this will let me use the display panel to give instant feedback of the image processing results rather than having to resort to my web browser. So I'm planning to use this for a number of projects over the coming weeks to fully explore what you can do with one of these little camera modules. Now, in my mind, as an end objective, I have the idea of building some sort of Microsoft Kinect style games controller for some retro gaming. But to begin with, we do need to get some basic code set up so that we can pull images from the camera, process them and display them on the LCD panel. So let's first have a look at what's inside this little LCD terminal and then get a simple motion detection application up and running so that we can verify that everything is working okay. The unit I have here is an ESP32 powered terminal with a 3.5-inch 480 by 320 pixel TFT panel with capacitive touch and an attached camera. Now, as you can see, the electronics are housed in a nice sleek plastic case with the camera dangling off on a ribbon cable at the top of the unit. Now, only a few of the ESP32 I/O pins are available for your projects, and those have been brought out to the edge of the board using Elecrow's own crowtail connectors. So on the top edge, we've got 4 I/O connections. 2 are labelled as analog and 2 labelled as digital. On the bottom edge, we've got the UART connection and an I2C channel that will let us expand our I/O count very easily. So the board also has a micro SD card slot for bulk storage, and on the other side then a LiPo battery connector, and it's got some built-in charging circuitry. So in essence, we've got really everything we need to develop some really interesting projects. If we now take a look inside the device by unscrewing the backplate, we get a bit more detail about how this thing is put together. So the main module is the ESP32 microcontroller itself. So this one is the ESP32 S3 N16R8, which is one of the best spec versions with a dual-core processor running at up to 240 MHz, 16 megabytes of flash memory for your code and files, and 8 megabytes of pseudo-static RAM to expand the internal 512 kilobytes of static RAM. Now, on top of this, it has the usual Wi-Fi and Bluetooth interfaces that you would expect on an ESP32. Additionally, on this unit, Elecrow have attached a MEMS microphone and a small buzzer, and I'm not quite sure whether that's just a simple buzzer or an actual speaker yet, but we'll find out later on. Now, power to the board is through a USB Type-C connector, and just above that we've got the reset and boot pins for programming the ESP32. The camera itself is attached via a removable ribbon cable, so I guess we could either remove the camera completely if we just wanted the LCD panel, or replace it with a slightly longer ribbon cable if we need to mount the camera in a different position. If we take a closer look then at these I/O ports, we can see that each of these crowtail connectors simply provides a power line, 0 volts, and then one of the ESP32's I/O connections. The only difference between the analog and digital ports is that the digital ports provide 5 volts, whereas the analog ports provide a 3.3 volt output. Now, I guess this simply makes them compatible with Elecrow's crowtail sensors, but in reality, it does give us 4 general purpose I/O lines in addition to our I2C interface for expansion. So, and if we look very closely at the circuit board silkscreen, we can see that each of the ESP32 I/O pin numbers are identified at each of the connectors. So I'm going to make a note of those for future reference. So that's actually a really nice unit to base our projects around. The extra features attached to this ESP32 module should give us enough power and memory to handle some quite intensive image processing tasks. So let's see if we can power this device up and get something happening on that screen. Now, it's worth pointing out at this point, obviously, I'm using this ready-made unit. If you want to, of course, you can just simply attach any SPI LCD screen, like this ILI 9341 driven one that I've used in a number of other projects. You'll just simply need to change some of the pin assignments when it comes to some of the software that we're looking at, but that should run just as well. So when you first power on the device, it's preloaded with one of the demo applications that come with its documentation. And this is a demo of an LVGL package. That is a graphics package and UI development system that the actual device is compatible with. So you can have a look at the website to get more information on this, and it does look like a very interesting piece of software that can help you get some really good looking user interfaces set up pretty quickly with your device. But I'm not going to be looking at that in this tutorial, just to mention that that does exist, and this little unit is compatible with that. But for the programming that we want to do at the moment, we'll need to get hold of the example software from the main product page. So I'll put a link to that in the description down below. And if you scroll down, you'll come to a link to the Learning Center for this. And the first thing this does is it shows you how to install the software so that we can actually get the Arduino IDE talking to our ESP32 device. So you need to go through those stages on there. And then we'll need to download a couple of libraries. So go to your manage your libraries, and inside there we need to install this Leuven GFX graphics system, which is basically a bit of a variation on the Adafruit graphics library. And then we'll need to download, of course, this LVGL library that lets us run those nice UI systems. And then lastly, we just need to download the lesson code, and that's at the bottom of the product page. So just simply download that and put that somewhere on your computer. So now we've got all of our code and libraries installed, we can have some fun with this device. So the first one we're going to do is we're going to have a look at one of the example bits of software, which is the A camera sketch. So if you go off and open that one up, you'll get this loaded up in your Arduino IDE. So we have our actual sketch file here, and then we have an include file, which will help us see which pins are required for the device. So in the normal sketch then, you can see that we're pulling in the various drivers and libraries that we need. We're then going to define the camera model as this Elecrow camera, and that will then, as we'll see in a second, will activate some pin numbers inside this header file. But what this does show us then is all of the pin assignments that we're going to need going on with this device. So you can see here we have all of the LCD SPI connections defined here with their pin numbers, and that of course then is being used later on here when it sets up this graphics driver to actually talk to our LCD screen, and you can see various bits of setting up going on in here. The other really important bit that we need then is of course this camera pins device header, and you can see that there are actually a number of standard ESP32 camera models defined in here, and you'll see them coming down here with the various devices. And the one we want obviously for ours is defined down the bottom in this Elecrow version. But what we'll find, this is a very, very helpful document for us, because it does tell us here the pin assignments that we need, and it does compare those in exactly the same format with other device models. So the Elecrow model isn't so well supported throughout the different example softwares that we'll see later on, but this does let us then create our own pin header setting file for our model, which will then allow us to hook into all the other example software. And again, we will see that in just a little while. But the one, of course, in the example file is actually set up for our device. Now, the only thing which you do need to change from the setup described on the help page is if we go into our tools menu, there is a partition scheme here for our memory, and you do need to set it up in this setup. So we need to have at least 3 megabytes of application flash setup, and then some more for this other memory here. If you don't do that, quite a few of the examples will fail with an out of memory error. So do make sure that you do update that before we start to run any of these applications. So I've already just set that running then, updating. So let's go on to the device and see if that actually gives us a camera feed coming directly from our camera onto the LCD screen. And powering it all up, we can see that we have on the right hand side there an image, and I apologize for the reflections on this, but we now have everything up and running and working. So we now have a working device, and we're aware of the pin assignments for both the LCD panel and the camera on our device. So that should let us then hook up to all of these other bits of software, which will help us explore this camera unit. Now, the one I'm going to be working with, and I'm going to be doing this over a few sort of weeks from now, is this Eloquent Arduino package. Now, this is a little course on some image processing and AI using your ESP32 camera unit. But it also includes a nice library, which in effect is a wrapper around the camera and some of the AI side of things, which gives you a nice framework and a nice interface to work with, rather than having to deal with a lot of the low-level hardware issues. So I'll put a link to this in the description down below. But really what this does then, if you have a look through here, as I say, it has this idea, it calls it a beautiful syntax. So in effect, a lot of these function calls here are, as I said, wrapping up a lot of the hard work in setting up the camera and so on, and simply then allowing us to concentrate on grabbing images, working with those images, and interpreting those images. Now, the one thing that this does, which I'm not planning to use so much, is that it does use a live streaming server. So in effect, it turns the ESP32 into a little web server, and the images that you see and the decoding of them and the image processing of them is all happening on there, and to see the results, obviously then you're working with this web server. So I may well use that, but my main objective here is to actually have this happening actually live on the LCD panel, and that's really how the main work that I'll be involved in translating these examples to do that. And again, you can see here what it's going to be going through here. So it's going to be doing very sort of motion detection, person detection, face detection, and that type of thing. But let's have a look at how I can use it. So I'll have a look at the very first thing that I've had to play about with, which is motion detection, and we'll see if we can get that up and running very quickly. So this is my version of the motion detection sketch from that Eloquent Arduino package. And again, you're going to have to modify some of it to get it to work with your particular model, and obviously then to work with the LCD panel. So I'm really just going to take you through now just a few of those changes that I've had to make. So on the main sketch listing, I am going to be displaying this on a screen, so I'm going to need some way of decoding some JPEG images. So the main Eloquent Arduino system uses the JPEG function on the camera to capture images, just to get the file sizes low so that we can process those nice and easily. Obviously that is not able to display directly onto the LCD panel, so we need some way of decoding those into the RGB565 for the panel display, and that's what this little library is going to do for me there. After that, we then of course need to have the LCD driver in place, and I'm really copying the exact code out of the original Elecrow example software, and you can see here that we're defining our LCD pins and then setting up the actual LCD panel itself, and that is exactly as it was on those other examples. Now, this system obviously needs to be able to talk to the camera, and that is handled by a set model pins header file in the actual library itself. It's not in the sketch files, that's actually in the Eloquent Arduino library files. So if you look for that, you'll find that there are a set of definitions for various models, which you can see here. So these are different models of ESP32 cameras. So we need to define one for the Elecrow. Now, the pin names that this particular library uses are not the same as the pin names from the Elecrow package that we saw earlier on, but because we do have some definitions here for camera models that will match up, we can actually match up the definition names with the definition names here, and this is what I've come up with for this particular package. So you can see here, and again, all of this code, I will put that onto a little GitHub repository which you can download and have a bit of a play about with. So that gets us, and again we have to produce this little function or this little method within this object to allow us to simply set up the model of our device. So back out to the main sketch then. So you can see we're doing a lot of setting up here and just getting everything up and running. So if I scroll down a bit more, and you can see that we're setting up our LCD panel and so on. We're then setting up our camera system and our actual motion detection software. So again, a lot of it is handled by these sort of quite high level method calls. So you can see here various setting resolutions and so on. It's quite handy. And there's where we're actually setting the camera model. These are various parameters for the motion detector system. And then down here, you'll see that we actually do then set up our screen. The only thing I've changed here is the rotation value, just to get it so we get the image correctly rotated onto that particular screen. There is a callback function here, so our JPEG images are decoded in blocks. So as it works its way through the JPEG image, it will draw various blocks of our image on the screen. And the way in which this is actually working is, this is our main motion detection loop. So we're going to capture a JPEG image from the camera. I'm then going to render that on the screen. We're then going to do some motion detection on that image. That basically takes our JPEG image, translates it down to a lower resolution monochrome image, and then examines each of these lower resolution pixels to see if they have changed between one frame and the next frame. And obviously a change in the intensity or the light intensity in that particular pixel is marked then as a bit of motion. Obviously there is noise going on, so we look for a particular amount of motion across the whole screen before we trigger some sort of motion. But what I'm doing here then is I am taking those lower resolution pixels. So each low resolution pixel is in effect 8 pixels by 8 pixels of the actual camera captured image. And all I'm doing is any of the ones which are detected as being changed, I'm going to draw a little red rectangle on top of the camera image so that we can see the motion detection taking place on top of the actual image itself, and that will tell us where it thinks it's seeing this motion. So that's the basic principle of this. And as I say there, this again, I'm really just using this as an exercise and showing you we have an example piece of software that is not configured the way we want it. So we're trying to shoehorn in both our LCD display rather than the web server display, and also we then have to make sure that our hardware definitions match up with the way in which the camera is being driven. So let's have a look and see if that works. So we've got our live video feed, and you can see as I move my hand into the frame, the camera is picking up that, and we are then decoding the changes in intensity into moving pixels on the screen, and that gives us our motion detection. So we've now got our full system ready to go, where we have a live camera feed, our image processing happening, and then displaying our actual image processing results directly on our own LCD panel. So that's really just a little bit of an introduction into this little device here, which is really a really neat little unit, and something which I'm going to have a bit of a play with in this motion detection and image processing side of things. And I just really want to show you how, in general, and obviously specifically with this device then, how we can use the ESP32 camera examples and the LCD examples and so on. By just switching around a few of the pin assignments, we can get a lot of those up and running quite quickly, and that lets us then have a good real play with this. And I'm saying my particular idea is having a lot of this image processing happening just live on the LCD panel itself, rather than having to go off and use a web browser. So I hope you find that useful. I hope you've enjoyed having a look at these things. Again, all the links to this product here itself and the various libraries I've used and so on will all be in the description. And don't forget, each of these tutorials that I produce, I also produce a blog page on my bytesandbits.co.uk website. So do please have a look at that as well. Any code you've seen here as well, I will try and put a lot of that up onto a little GitHub repository so you can get hold of that and see exactly what I did. So if you're enjoying what I'm doing on this channel, please do make sure that you like the videos, subscribe to the channel, and hit that notification bell so that you can find out when my next videos are being produced. I hope you like this one. I look forward to seeing you again in another video very soon. So bye for now. For more games programming, electronics projects, and retro gaming, please make sure you like this video, subscribe to my YouTube channel, and visit my website.